And what I mean by that is that I knew I would catch somebody yesterday where they didn't listen to what I was talking about, and they would watch me do the one problem we did in class and then go submit that answer as the question of the day. And that wasn't it, right? The question yesterday was, look at the 3 problems I provided you on the Google form. There was like a picture or a document, you could have opened either one, and you had to tell me the answers for all 3 of those. And I caught a couple of people yesterday where they didn't even pay attention to my directions. They just submitted that one answer and like, that's the thing you did in class today. No, it's not what the question asked for. So we might do more of those where I just kind of give you a quick problem and have you try it out. So for those who submitted it to me, thank you. You got points for just attempting it. If you did not submit anything to me, you did not get points. So that's kind of how it works. So you either have to be in class paying attention and kind of actively participating. Thank you for those, those last couple days, for the people online and you guys who were online yesterday and the couple days before who are like, actively participating, asking questions, throwing out answers. It makes it a lot easier. It feels like class kind of a little bit. So I always appreciate that. So keep that up. I know it's tough to, kind of volunteer answers in front of your peers, but it does make it worthwhile for you to figure out how to do stuff, especially if you want to guarantee if you're right or wrong or you want to check. So thank you for that. But yeah, so if you're ever, if you're not in class, let's say you're sick, you're gone, you have an appointment, I will always send you the link for the classroom. Make sure you're always checking into the Zoom. Set alarms for yourself. Wednesdays are early out days. I stick to that schedule. Some people got caught by that yesterday. Pay attention to the email. I have the times on the email. So it's not like I'm just copy pasting it from Tuesday. I assigned a new time. So kind of pay attention to that. Here's what we're doing today. You can look up here. We're gonna do one more day of completing the square. We've been doing this the last 6 days in here. So if you've not been paying attention the last 6 days, then it's understandable that you don't know what's going on. So you can go back and watch the videos we've done. I've posted every video, every lesson we've done on my website. So you should be going and watching those over and over and over until you get good at this stuff. But the big thing for a reminder is that we were talking about max and minimum values. That was the new thing I think I introduced for the first time on Tuesday? We introduced that. And then yesterday we did a couple problems in class, and today we're doing a few more. There's something I need to clarify, and I brought it up yesterday. It was the last question, and I said we are going to have to talk about this problem tomorrow because there's a situation that I didn't even foresee. I didn't see a problem with it until I was double checking answers as we went. So if you didn't notice, I was writing down problems, and I had my hand on my computer and I was graphing stuff as we were doing it. So I was kind of clicking, kind of making sure the graph was in front of me of each problem. And there's an issue, and I want to bring it up today. So that's what we're going to look at. There's something we have to settle. We have to make sure that you understand how to do a problem correctly. I haven't. I wouldn't want to say I misinformed you. We need to clarify something so you get a right answer. So, correct answer. All right. So, at home, does everyone see my iPad screen? Are you getting that? Yeah. Okay. I'm getting the heads up. Okay. Thumbs up. All right. Let's walk through the in-class activities yesterday. So this is the in-class activity we did. You had to submit your max or minimum value for the problems we did. These were the 3 that was on the Google form question. This was a picture or was a document. I don't care which one you open. If you ever have struggles opening, that's why I have the other one there. Some people's home computers can't open a Word document, so I have the picture. If you're having problems with Google Classroom opening that, in Google Classroom, you can assign it an app so it will open on a certain app for you. So keep that in mind. If you're really struggling at opening up pictures, you can assign it a different app to open it. So on your phone or your personal device, you can download an app for free through Google, so it'll open up those things correctly. So keep that in mind. All right, so we have 3 problems here. This is going to be just my first slide. My goal is to go through 3 slides today. 3. This is the first slide out of 3. The third slide we do is the one I want you to submit to me today. So if you already have checked on Google Classroom, maybe you have that open all day, and you've noticed that the question of the day has already come through. I think it came through about 10 minutes ago, maybe. And you're wondering, what is the question? What is it asking for today? The question today is on the third problem we do, the third slide. I'll highlight it when we get there. you have to submit its maximum or minimum value, the solution to the problem, the max or min. Okay, does that make sense, what we're doing today? I'll highlight that when we get there, and then you can go fill it out. We're not getting homework today. It's just notes, and we're done. We might be done pretty early today, so you can get a chance to relax for a little bit, ask questions, decompress a little bit. Welcome back to class. So, okay, we ready? Let's walk through it. So, let's see, am I recording everything? Oh yeah, we're good. Okay, so, max and minimum value. Let's do the top one. We're going to do it as normal. So when we do this, we have to complete the square. So if you don't remember the completing the square process, you have to move that constant to the other side. So I'd move that 8 to the other side, make it a negative 8. That was the first step. Notice on this problem, there's no leading coefficient. That's good. We don't have to deal with it. The second problem we do, and that's the one we need to clarify. That's one of the problems we have to talk about today, is actually that one. And then what we did next is you take half the middle, so I'm going to underline the middle term. This is technically the middle term when you put it in descending order. What is half of 9? 4.5, okay? Then we have to square it, right? Half the middle squared. Well, 4.5 squared is 20.25 if you actually multiply it out. And that's what we're going to magically add to both sides. 20.25 plus 20.25. Again, I'm going to just clarify my calculator. 4.25 squared, yes, 20.25, did it right. Okay, so we've done that. And on the left side here, we should be able to factor this thing apart. The right side, I don't really even care about it. If you want to just leave that as 28.25 over there, let me write the 2. Come on. Why does it do this to me all the time? That's so weird. Okay. Anyway, 28.25, right? And now when we factor the left side, factoring again, it's just normal trinomial rule. What are my parentheses going to be? What was the rules we talked about on the left side? What do you think?
Would that not be 28.25 because it's a negative 8?
Oh, yeah, you're right. Oh, good call. Good call. Hold on.
Good.
Yeah, good call now. Didn't catch that negative sign. Thank you for that. Good call now. Okay, let's keep going now. Good catch. I don't know who said it. Good catch. All right, we're going to come back to that. All right. What were you saying? It was x plus 4.5 and then x plus 4.5. All right, because again, what we talked about in class, it's x and x, and then on trinomial rule, it's the same symbols, right? They're both plus signs, and it's always, the rule that I told you, it's always half the middle. That's what's going to be in those two parentheses. Perfect. Now, on the right side, yes, I'm an idiot. 20.25 minus 8. What is that? 12.25. There we go. All right, now we're off to the... Oh my gosh, it won't let me write the 5 again. Why? Oh my God. I'm going to lose my mind on this iPad. Why? It's just messing with me. It won't let me write in like that one location. And it's every iPad I own, it does this. It's so weird. Why do they have that weird feature? All right. Anyway. All right. So at this point, the two parentheses match. And we have x plus 4.5 squared. And we have the 12.25. Okay. This is where we stop. This is the new stuff, right? The new stuff, this stuff that we're going to be getting homework on tomorrow, you'd stop here and you'd tell me the coordinate. Where is the max or min at? So you tell me the number, the opposite number with the x, which is? Negative 4.5. And then the opposite number on the other side, which is? 12.25. And this is the coordinate for the max and min. That's it. Done. Right? We've been doing this last like 4 days here. Okay? Now, that again, this value is actually a minimum. Why know that this is a minimum number on a graph? If you look at the original power, it's x squared, right? The tails have to go the same direction. If we think back to the Unit 1 chapter test we did, it's x squared, so the tails go the same direction. They're going up by normal standards. And so this thing would be like a bowl, and it's coming down to a peak, like a point at the very bottom. We call that a vertex. So the minimum point is also known as a vertex. That's a little vocab term for you. That's the coordinate right there. That's it. Done. We move on to the next problem. Is there any questions with that? That's what I wanted on the Google form question yesterday. Now, how this is different than the stuff we did earlier this week. The assignment that was due, I think, Tuesday, correct? No, it was yesterday. Assignment we had to do yesterday. It was Wednesday night. It was due at 11:59 last night, right? That was finding the roots to a problem, right? Finding, using the completing the square and finding the roots, where it hits the x-axis, the x-intercepts, zeros, whatever you want to call them. That math required that, let me get rid of all this stuff here. That math required that you went from this point and you just went a couple extra steps and you solve for x, where you do this. This is the only difference between like the new stuff and what we did the last couple days in here, is you take this power to the other side and you do a square root on your calculator. Because you take that power of 2 off, right? And it becomes a square root. That's the opposite of a square. It's called a square root. And then you'd subtract the 4.5 across. Let's change the color. Let's go to a red color. So this would be x is equal to negative 4.5 plus or minus whatever that square root of 12.25 is. And those are your roots. If you type that in your calculator, it's negative 4.5 plus whatever that square root is, and then negative 4.5 minus whatever that square root is. And you get your 2 answers, and that's what the roots are. That's your x-intercepts. Do we see the difference between what we did previously and what we're doing now? Okay, not too bad. It's not like we're doing like drastic, crazy steps that are way different. But there's an issue, and I want you to see it. I'm going to point something out. In fact, I'm even going to graph it for you and share it on a graph. So that's what we're going to look at here in a second. In fact, I'm going to type out this graph before I get there just to show you the issue, and I'm going to share this picture with you here in a second. I'm going to do it for this next problem. But this next one doesn't even have the issue, does it? No, the next one doesn't have it. It'll have to be one of the other examples I do. Okay, anyway. Okay, is there any questions with the last one, though? Okay, I'm going to erase this. I've been taking screenshots, so I'll share all the screenshots when we go to when I put on my website so you can see all the work, because I know my picture-in-picture gets in the way sometimes, so I always post all the pictures we've been doing. All right, but let's go to the second problem. And here's what I've told you to do, okay? When we get to these problems where they have a leading coefficient, you can see that they have a 2 out front. I told you to divide everything by 2, right? X squared plus 2x plus 1 equals 0, and then you just start the problem, right? On certain problems, that works. That's something I didn't really, I didn't think about too much. It works on certain problems, very nice, clean problems, like this one. It works on this one just because of pure coincidence. But on other problems, it won't. And those are the next 2 slides I need to show you, that it works in certain cases and it doesn't work in other cases. But I want to show you what we did correct and how you can fix your answer to make sure that you always get it right. So, but on this one, we divided everything by 2. We took the 1 to the other side. This is what I've been telling you to do. This is just doing the same work we've been doing, right? You take the 1, we drag it over to the other side, it's negative 1. And then we do half the middle squared. Well, what's half of the middle here? Yeah, so, well, the middle number is 2, right? We take half it, which is 1, and we square it, which is 1 again. And that's what I'm at. So half the middle squared. And so this right side over here, if I don't get this wrong for once, this right side turns out to be a 0. And this left side, I can factor this thing apart. So it's a trinomial factor, and we get this. And then you read off your coordinate. Right? This is what we've been doing the last few days in here. So this ends up being, what, negative 1 and a 0, because you can't do an opposite. Now, the reason why it works on this one is because that number was so special. It ended up hitting 0. Makes sense? Like it was negative 1 comma 0. And if I look back at the examples I provided, it was kind of always the same idea. Every problem I kind of picked, it was always hitting a 0 or something like that. When it doesn't hit 0, negative 1 comma 0, we technically have a wrong answer. and we have to make sure we fix it. So that's something I want to show you. That's going to be the next 2 slides. But this is the correct, that is the correct vertex. It's the actual lowest point on that graph. Just by dumb luck. So, all right. So, let's keep going. Let's do the, oh, I shouldn't have done that. All right, let me take a screenshot of that. All right. And let's now, we can erase, because now we have the screenshot of that thing. Okay, so, next problem here. Same thing, move the 11 across. We have, I'll put it up here, x squared plus 10x. We add the 11 across, and we do, you know, completing the square. So, what is half the middle? Yeah, 5. We square it, which is 25, and that's the number we're magically adding to both sides. And then we have to factor this left side apart. It's the same parenthesis repeated twice. It's going to be x. It's going to be a plus and plus. It'll be half the middle, which is 5 and 5. And so there's 2 of those parentheses. I'm just going to shortcut it to that point. And we have a 36 on the other side. Oh my goodness. Just let me write the 6. And now we read off what my coordinate is. So what is the coordinate for this particular problem?
-5.
And? -36. Okay. Are we good with that? In fact, let me just share a graph with you here. So, for those who are at home, I'm going to I'll share this graph. I'll actually take a picture of it here just so you can see this. 10x. We have the -11. All right. I'm gonna just take a screenshot of this here just so you can see this. Okay, and let me share that screenshot with everybody in the room here.
Hey, Ward.
What's up? Hello?
Ward.
Hello?
Those are the answers to our question of the day.
Yes. Those are the answers for the Google question yesterday.
Post the question of the day?
What?
Oh.
Those are the questions from yesterday.
Wait, what? Why are we doing them again?
Because some of you didn't get the right answers.
Oh.
Oh. Just kind of going over the questions. It's kind of nice to see the answers.
So what are we doing today for our question of the day?
The last slide. Were you not paying attention, Kylie? I said it, right? I said the last slide. Where have you been? All right.
How many more slides do we have?
2.
Okay.
Okay. All right. Anyway. All right. Can everyone see the picture here? You can see the graph. It's dipping all the way down. It's hitting -36 at the very bottom. And you can see where I'm at. I'm at -5 over. And then if you follow the -5 down on the x-axis all the way to the bottom, it's hitting -36. Do you see that that is a minimum value? And again, if we go back to that last problem, you can see why it's working, right? You can see the coordinates. You can see that when I look at this original problem, this thing, the tails go up because it's a power of 2, right? And it's a positive, so the tails go up, so the dipping point would be at the bottom, so it's a minimum. So this is a minimum value for that vertex. It's the lowest point on that graph. Okay, so now to get to Kylie's question and stuff, what are the questions we have to do today? We have a certain type of problem we have to talk about that I may have misinformed you, and I want to clarify something. It's when there's leading numbers out front, leading coefficients, and they're not special cases. Like the problem I put on your property sheet, this problem here on your worksheet was a special case. So it worked the way that you did it. But they don't always work that way. And I actually want you to see it here. So that's what we're going to look at, okay? All right, so here's the second to last slide. So we're going to do this slide and we'll do one more and then we're done. And these will be pretty quick. All right, so here it is. This is the problem I'd like you to write down. This is not a special case. It is something we need to clarify. I want to find the vertex, the lowest point on this graph. The graph is going up. The tails go the same direction. It's positive 2x squared, right? So the tails are going up. They're going the same direction. So we're finding a minimum of vertex. On this problem, if you follow the rules I told you and divide everything by 2, and then you go ahead and you complete the square, your vertex will be off. It will be off by a hair. Okay? And I want to clarify why. And this is just something I want you to see. Okay? I still follow the same first step. I would still move this 8 across. And what happens when I move the 8 across? It becomes positive, right? Because it was negative, it turns positive now. Notice, I didn't divide anything by 2 yet. This is the proper way to do it. In fact, I'm going to say this is the, I'm going to put this in the corner. This is the correct approach. This is the correct approach to this problem. This is the correct way to do it when there's a leading number out front. And I'll explain that. I'll show you why it would be off and how you can correct your answer if you ever just want to do it the old way that I showed you. Because I didn't really think about it. Okay, so we've done that. We moved the 8 over. Fine, dandy. Do we agree that this thing has a leading number out front, though? So instead of dividing everything by 2, I'm going to factor the 2 off of it. That is the subtle difference that I'm going to do. And on the other side, that 8 is not affected. Because do you agree that on the left side, those items had 2's, and then there's an equal sign. So everything past the equal sign is not affected when I factor. I pulled it out. So I'm factoring out the 2. I'm not really dividing it. I'm just pulling it outside the parentheses. It's like a common factor in factoring. Okay, so now on this problem, now you can see your trinomial here. This is supposed to be a trinomial, 3 items. What is the middle item? 2, right? What's half of it?
1.
Square it.
2. 1.
1, thanks. 1, okay. Half the middle squared is 1. But I'm not going to add 1 to both sides. Right, because that's what we did last, right? We just half the middle squared, add it to both sides. But why don't I just add a 1 over here all of a sudden? Why am I not just adding a 1 over? What am I forgetting about this problem? Yeah. There is a 2 out front. Before, we never really dealt with it. We just divided it off. It's technically incorrect. It's still technically out front. I just factored it off. So really, the number I'm adding to both sides is actually a 2. Because if I were to distribute, if I were to distribute this 2 back through this parenthesis, it would end up being a 2 there. If that makes any sense to you. And so on the other side I have a 10, and over here this side is ready to be factored apart. So how do I factor that part in the parenthesis? What do I do? How do I factor x squared plus 2x plus 1? What's the normal factoring of it? Say it? X. Yeah, it's x plus 1 times x plus 1, right? So there's 2 of them. It's still, x and x plus plus, it's half the middle, right? So, at this point, right here, what is my vertex? What's my vertex?
-1.
-1, -10, right? That is the correct vertex. That's correct. What we were doing was dividing everything by 2, right? Dividing everything by 2, and doing my process, and my vertex would have been wrong. My vertex would have been off. It would have actually been half as far away, been half as tall, or half as deep as it needs to be. This thing is hitting -1, -10. So just to show the point, I don't want you to write this next thing. So just kind of watch. So this is what we did previously. We divided everything by 2. All right, we divide everything by 2 if there's a leading number out front. This is not the correct work. This is not right. Not correct. So we divided everything by 2. We move the 4 over. you took half the middle, square it, you add it to both sides. We factored this side apart. This side turned out to be a 5 over here. This was x plus 1, x plus 1. That was half the middle, which is x plus 1 squared. And we get a 5 over here, and then we read off my numbers, which was -1 and -5. And do you see that the coordinate's off? It's off by the exact factor that you divided by. It's twice as far off.
So, times by 2.
You could. So if you knew what number you divided off, that's a way to correct your answer. If you know what number you divided off in the beginning, you can multiply it back into your answer. And so you'd have to do it to this number. You just multiply it by 2, the number you divided off. But now notice, that number stayed the same. Yes? See how that number, the 1 stayed the same? So here's another way you could correct your answer. You could, if you were keeping track, you could just multiply your answer, you know, that thing by 2, or forget about the number on this side. Just forget about the 5. Just tell me what the x number is. The x is a -1. And if you want to know where the vertex is, just plug -1 back in up here. If you plug a -1 in, it'll tell you 10. It'll tell you the -10 out of that thing if I were to plug a -1 in there. It's kind of crazy how that works. It'll actually tell you the right number. So, all right, questions. So I wanted you to see that. Now, what brought this into my head? And it wasn't. Ooh, I shouldn't erase it. What brought this? What made me think of this was the second problem we did yesterday. It was the second one, and you know we were doing all and we were drawing it, and I'm like, oh, this thing, you know, it's facing downwards. It was a negative problem. In fact, you know, this is the second. This is like the problem we did yesterday. So if you want to write this down, this is my last slide. This is the one you'd be answering for me on your Google form question. So to answer your question, Kylie, this is the one you're going to submit to me. All right, what makes this one special, this is a special case, it has a negative sign out front. The negative sign is there. So the bowl actually faces down, right? The bowl faces down. And so it actually has a maximum on this graph. So we're going to have the vertex will actually be a maximum. A max height, right? And when we were doing the problem, I was thinking, I'm like, this thing has a height. And the number we came up with made no sense on the problem we did. Because it had a height, and I could, you know, we wrote down the coordinate for it. And then I was thinking about it, I'm like, well, this thing had roots. I know it did. We did it in class. It has roots. But the graph that we were coming up with yesterday, the height was here. It was like -1, it was like 1, -2 or something like that. And that was the highest point on the graph we found. Did that thing hit the x-axis?
No.
No, it didn't. So how would it have roots? Because we found it had roots. It's because of this idea what I'm showing you today, is that we didn't factor out that number out front. So in fact, the graph was actually twice as far away as where it should have been. It should have been above the x-axis, not below it. We were twice as far away from its normal location. And that was just the idea, what we were talking about with that idea. So I'm going to show you this problem one more time, and then what we're going to do tomorrow is we're just going to practice this over and over to make sure we correct that mistake that I've shown you. So, okay, so we're gonna move that 15 to the other side, so it's -15. This is the correct way of doing it again. So I move the 15 over. We factor out the number in front of your x squared. So in my case, I'm going to factor out a -5. So if I pull out a -5 out of that thing, what's going to be left in the parentheses? Say it again.
X squared minus
4x. Yeah, because I divide the -5 out, so I'll have a -4x there if I divide the 5 out. And now we do the completing the square process. Half the middle squared. Well, this is your trinomial. The middle's a -4. We take half of it, which is -2. We square that, which is 4. And I'm not going to add a 4 to the other side because you have to think about it. This 4 will be multiplied on this -5 out front. And that's what I'm going to put on the other side. So 4, because that's half the middle squared, times the -5 out front, which is a -20. And that's what we're putting on the other side. So this problem ends up being -5. I'm going to factor this thing apart. And on the other side, I have a -35. And if I factor this left side up, that's x, and half the middle is a -2. So what is the coordinate on this particular problem? Where's my vertex? 235? 2 positive 35, right? And I want to show you that this actually does work. So I'm actually going to graph this. This is my last thing today. It's my last graph. So what is this? -5x squared plus 20x plus 15. I want to just show you that this is the correct graph. I'm going to share this with my iPad screen so you guys can see this. There it is. So, we look at this graph. If I can get the directions to go away. It's hitting, it's going over 2 and up 35, and that's the maximum height. So, all right, does that make sense what we're doing now? The little correction we have to make. Subtle change, but it made a big difference in terms of vertex, and it was something I didn't even foresee until I saw I kept giving you special cases, that it was always being the right number, but it's not going to work for every problem. This is the correct way to do it. So we'll practice this a little more tomorrow. That's it for today. So